Today we will solve the problem 4.2 of the Griffith third edition quantum mechanics concept and applications. The problem 4.2 is related to the infinite cubical well, that is three-dimensional potential well, or we can call it as a particle in a box. Here the potential is V, which is a function of x, y, z is equal to 0. Uh, that is when x, y, z all between 0 to a, where a is the box length naturally. And it is infinite otherwise. So between the box inside the box 0 to a, if the potential is 0, outside it is infinite. So now the this question contains three parts. Part A is find the stationary states and corresponding energies. Now we are going to see part A. Then we will see B and C. In three-dimensional infinite square well potential, the Schrödinger equation can be written as minus h cross squared over 2m multiplied with delta 2 over delta x2 plus delta 2 over delta y2 plus delta 2 over delta z2 multiplied by psi, which is equal to E psi. Here, inside the box, the potential is 0. So, we made potential is equal to 0. So, we have taken the free particle Schrödinger wave equation in three-dimensional one. So, here, the wave function psi is a function of x, y, z. So, we are separating the variable using the separation of variable, that is psi psi of r is equal to x of x, y of y, and z of z, where r represents the radial coordinate x, y, z. Now, what you are going to do is you replace psi by this term and divide by it. That is, replace psi of r by x, y, z, and divide by x, y, z. Then this equation, the Schrödinger equation will become, after separation of variable, it will become 1 over x, t squared x over tx squared plus 1 over y, t squared y over ty squared uh, plus 1 over z t squared z over tz square, which is equal to E psi. That is this one, which is equal to. So we have now separated the variable. So since the first term purely depends on x, uh, so we made the partial derivative into full derivative. Same is the case with the second term and the third term. Now what we have done is this minus h cross squared over 2m we have brought to the right hand side. So that will become minus 2m over h cross squared. Naturally, we are replacing psi by xyz and dividing by xyz. So in the right hand side, there is no xyz. This is our final equation that we have arrived. After separating the variable, we got this expression. Here you look into the left hand side. Left hand side, each term is independent of others because the first term depends only on x, not on y, z. Similarly, other two terms. Now we know is a well established solution. Solution for the first term is minus kx squared times capital X. Second term, it's minus ky squared capital Y and minus kz squared capital Z, which is equal to minus 2m over h cross squared E. So which implies you can remove all negative sign, then it will become kx squared, just kx squared capital X plus ky squared capital Y plus kz squared capital Z which is equal to 2m over h cross squared E. Uh, then now we have to find the value E. In order to find E, you bring this 2m over h cross squared to the left hand side again. Then we will get here the energy I am writing in terms of nx, ny, and E sub nx, ny, nz. Nx, ny, nz are the node along xyz direction, which is equal to h cross squared over 2m times the kx squared plus ky squared plus kz squared. Now, you know that k from the infinite square well potential, we know k is equal to, sorry, 1 minute. That is k is k is equal to n by a. We have seen k is equal to n pi a, where a is the box length. Then if you replace this kx by nx by a, that is nx along x direction. So this equation will become E sub nx ny nz is equal to h cross squared over 2m times this. I am replacing k by this one. So which is equal to nx squared pi squared over a squared plus n pi squared uh, ny squared into pi squared divided by a squared plus nz squared uh, pi squared over a squared. Now, see in the denominator, you have a squared as a common in all three terms, and in the numerator, you have pi squared. So you bring pi squared divided by a squared outside the bracket, then you will get right hand side I am leaving as it is. The sorry, left hand side I am leaving as it is. E sub nx ny nz, which is equal to uh, pi squared h cross squared over 2 m a squared uh, multiplied by this nx squared plus ny squared plus nz squared. So we will get all these three terms, uh, which is equal to Eg1 nx squared plus ny squared plus nz squared. Here, what is Eg1? Here you can see the constant pi squared h cross squared over 2ma squared. From particle in a box, one-dimensional box, it is the lowest energy state. That is ground state energy. So I have represented this as Eg sub g. And in order to indicate this a one-dimensional one, I have referred to this as Eg1. So this pi squared h cross squared over 2ma squared is equal to Eg1. That's what I have written here. So we can simply remember that E sub nx ny nz, that is energy in the three-dimensional case, is equal to Eg1, that is a ground state energy of one-dimensional case, multiplied by nx squared plus ny squared plus nz squared. So we got this expression finally. Then the corresponding wave function, you know, what is the corresponding wave function, which is a function of x, y, z, which is equal to ax, ay, az, sine kx x, and sine ky of y, and sine kz of z. Here, what about the normalization constant? A normalization constant, since it's a cubical box, the normalization constant is the same in all directions. That is, psi xyz is square root of 2 by a into square root of 2 pi a into square root of 2 pi a. Sine this kx, I have told you that it is nx pi over a x, and I have replaced ky as ny pi a, and similarly kz pi nz pi a. So, since it's a cubical box, the normalization constant we have seen in the case of one-dimensional potential well, which is equal to square root of 2 pi a. So, if you multiply the square root of 2 pi a thrice, then you will get, you keep left hand side as it is, right hand side will become 2 pi a power 3 by 2 sine nx pi over a x into sine ny pi a y and sine nz pi over a z. So we will get this. This is the wave function for a cubical box, and this is the energy state of this cubical box. So we have obtained all, that is the energy level of the system as well as the wave function of the system in the case of cubical infinite square well potential. Now the section P is called the distributed energies as E1, E2, E sub 1, E sub 2, E sub 3, and it will go up to En. In order of increasing energy, find the E1, E2, E3, E4 and E6 and determine their degeneracy. You know what is a degeneracy? The same energy level with different energy state. So first you take lowest energy state where Nx, Ny, Nz is equal to 1. See, we have seen the energy state is equal to Eg1 Nx squared plus Ny squared plus Nz squared. So in the case of 1, 1, 1, all are 1, 1, 1, then this will be 3 times Eg1. So 3 times Eg1, we are calling it as first energy state in the cubical square well potential. Cubical potential well, infinite potential well, in fact. So there is no degeneracy, only one energy state without any other options. N equal to 0, not allowed, of course. Here. Then next energy level, you have to raise any node at along any one direction by 1. So it can be done either on x direction or y direction or z direction. So you will get three combination 2 1 1 1 2 1 1 1 2. That is you are increasing the node along x direction. This is along y direction. This is along z direction. So if you apply here 2 squared plus 1 squared plus 1 squared, so 4 plus 1 plus 1, 6. 6 times the ground state energy of one-dimensional square well potential. So same energy level, but different state. So degeneracy is 3 here. Then you increase the energy to the next level. So you have to increase any one of these two to increase any one of these two x along xy direction, xyz direction. Now you can increase 1 by 2. So 2 2 1 2 1 2 1 2 2. So these are the possible permutation combination. So next level 2 squared plus 2 squared plus 1 is equal to 9. That is 9 times Eg1. So that we are calling as E3. That is next energy state. So here degeneracy is 3. Similarly, you rise further. Then next energy level can be obtained when you are rising one of the node along either along x direction or y direction or z direction by 3. So next to 2 by 1, that is 3 along x direction, along y direction, along z direction. All other are 1. So there are three different permutation combination. So 3 squared plus 1 squared plus 1 squared will become 11. So 11 times EG1. So that is E4, E sub 4. Here also degeneracy is 3. Then you take all to next energy level. Then next to 11 EG1, you will get 12 EG1. That is 2 squared plus 2 squared plus 2 squared, which is having, there is no degeneracy because all are, what there are only one energy state for the corresponding energy level of the 12 EG1. So this is 1. Then you come to next energy state. You increase, uh, next energy state can be obtained when you are making 3 to 1. Next 13 is not possible. Same wise, here I want to explain 4 and 5 not possible. 7, 8 not possible, 10 not possible because you cannot get these numbers by squaring and adding some integers. So next energy level is 14. 14 you will get 3 to 1. 3 squared plus 2 squared plus 1 squared is 14. Here you can have 6 permutation combination. That is 3 you keep as it is along x direction, or 2 1 1 2. Then 2 you keep along the x direction, then 3 1 1 3. Then you keep 1 along the x direction, 10 2 3 3 2. There are 6 possible combinations. Here you can analyze if all nodes in all directions are same, there is no degeneracy. If nodes of any two direction is same, then you will have degeneracy of 3. If all are different, then you will have degeneracy of 6. Only 3 possibility. There is an exemption. We are going to come to it in section C. So 1, 3, 6. That is uh, all node. If all node are same means no degeneracy. If any two node are same, then it is degeneracy is 3. If all are different, this degeneracy is 6. So we have seen up to 14 EG1. Then next energy state we will get 16. Next to 14 we will get 17. 15 and 16 is not possible by adding the square of any three integer. So next energy state is 17 EG1, which can be obtained by 3 to 2. So 3 to 2, there is 2 are equal. One node is different, so you will get a degeneracy of 3. Then next higher energy state is 18 EG1, which we will obtain by squaring and adding. That is 4 squared, 1 squared plus 1 squared. So 16 plus 1 plus 1, 18. So two are same. So naturally degeneracy is 3. Next combination is we can have 3 3 1, which is equal to 9 plus 9, 18 plus 1, 19, 19 EG1. Next energy state is 19 EG1. Since two nodes are same, so naturally you will have degeneracy of 3. Then next one is 20 not possible, 21 EG1. We can obtain by adding, squaring and adding 4 to 1. 4 squared plus 2 squared plus 1 squared is 21. All three are different nodes, so you will get degeneracy of 6. Then next energy state is 22 EG1, which we can obtain by squaring and adding 3 3 2. That is 3 squared plus 3 squared plus 2 squared. So two nodes are same, one number is different, so naturally you will have degeneracy of 3. Next also same thing, 4 to 2 you will get to 24 EG1. So two are same, so you will get a degeneracy of 3. Next, another is next energy state is 26 times the ground state energy of the one-dimensional particle in the box. So you can obtain 26 by squaring and adding 431. So all three are different. So naturally you will have six degeneracies, six. Now, very interesting case, you come to 27. Can be obtained 3 squared plus 3 squared plus 3 squared, 27 EG1. So all three are same. So naturally you will get, you will not get any degeneracy. But because of that number accidentally, we will get this 27 by adding 5 squared plus 1 squared plus 1 squared. So you are not supposed to get degeneracy when all three states are same. But however, here the situation is different. So you will get another combination by squaring and adding 5, 1, 1. So here the degeneracy level is 2. That is a very interesting case for E14. So thank you very much for watching my videos and supporting me continuously. Thank you very much.